Welcome to the Is It Worth Watching show. Today, we'll delve into a fascinating discussion about AI advancements and the trajectory from visual spatial intelligence to the cutting-edge innovations shaping our future. I'm Jake, and I'm joined by my co-host Jill.
We're exploring the evolution of AI from its early days through significant breakthroughs in deep learning and neural networks to new advancements in spatial intelligence. Our focus will highlight insights from leading experts who have been at the forefront of these technological revolutions.
Diving into the captivating history of AI, it's fascinating to observe how it evolved from its conceptual roots into the remarkable technology we see today. From the early theoretical underpinnings in the mid-20th century, like Alan Turing's pioneering work, to the AI winters marked by funding cuts and skepticism, the journey has been anything but straightforward.
Yes, the incorporation of machine learning algorithms, along with exponential growth in computational power, has significantly accelerated AI's development. The shift from symbolic AI to the data-driven approaches we rely on today, such as deep learning, marks a substantial leap in how machines can learn patterns and make decisions. This evolution has been punctuated by key breakthroughs, from IBM's Deep Blue defeating Garry Kasparov to the more recent successes of neural networks in image and speech recognition.
These milestones highlight AI's transformation from a niche academic interest to a cornerstone of modern technology, impacting industries across the board. From healthcare and finance to entertainment and transportation, AI's applications continue to expand and evolve, showcasing its potential to reshape our world. Imagine a world without the advanced AI we have today. At the core of these incredible advancements is the sheer amount of compute power driving them forward. The burgeoning capabilities of AI have hinged greatly on the evolution and availability of sophisticated computational resources. Take, for instance, the leap from experiments that took days on early GPUs to those we can now run in mere minutes on modern GPUs. It's fascinating to see how increased compute capacity has enabled more complex models and accelerated the pace of innovation.
This dramatic growth in compute power has not only sped up development cycles, but also allows for the handling of much larger datasets. These vast datasets are critical because they drive the accuracy and sophistication of AI models. More powerful computing resources have made it possible to train deep learning models with billions of parameters, unlocking capabilities that were previously unimaginable. Without these advancements in compute, many of the strides we've seen in areas like natural language processing and computer vision would simply not be possible.
The world of AI has seen some groundbreaking developments over the years, and one of the most transformative is undoubtedly the advent of deep learning. With its ability to leverage massive amounts of data and unprecedented compute power, deep learning has brought AI from theoretical concepts into tangible, real-world applications.
Absolutely right. Before deep learning, AI was somewhat constrained by the limits of the algorithms and the datasets we had. But the ability to analyze large datasets in ways that simulate human neural networks has revolutionized fields from natural language processing to computer vision.
Take, for example, the way deep learning has impacted image recognition. Projects like ImageNet made use of neural networks to identify objects in images with a level of accuracy that was previously unimaginable. This progress has paved the way for more advanced applications such as autonomous vehicles and advanced medical diagnostics.
And it's not just imaging. Language models have shown incredible leaps as well, with systems that can generate human-like text, translating languages, and even writing coherent essays. The success of systems like GPT-3 highlights how deep learning can be leveraged to understand and process language at scales we never thought possible.
Picture this: a sea of images from all over the internet curated into a massive dataset. That's what ImageNet is, one of the most influential datasets in the AI and machine learning community. It consists of millions of labeled images organized according to the WordNet hierarchy, making it a powerful resource for training and benchmarking deep learning models.
ImageNet has significantly impacted the field of computer vision by providing a vast and diverse training ground for algorithms. Its annual ImageNet Large-Scale Visual Recognition Challenge, ILSVRC, has driven innovation, resulting in groundbreaking models like AlexNet, which was a huge leap forward in 2012 by drastically improving accuracy rates.
The introduction of ImageNet transformed how researchers approached visual recognition tasks. pushing the boundaries of what was possible. It also played a pivotal role in the rise of deep learning, as larger and larger neural networks were trained on this extensive collection of images, leading to improvements in various real-world applications such as autonomous driving and medical imaging.
By standardizing a benchmark, ImageNet provided a common ground for comparing different techniques, fostering rapid advancements in the field. The dataset's structure and scale challenged researchers to refine their models, ultimately raising the bar for both academic research and industry implementations.
The journey of AI has been quite fascinating, especially when we consider the transition from supervised learning to generative models. Initially, supervised learning dominated the scene, with its focus on using labeled datasets to train models for specific tasks, such as image recognition and language translation. This approach required large amounts of annotated data, which was not only time-consuming to gather, but also limited in scope.
In contrast, generative models have revolutionized the field by enabling machines to create new data that weren't explicitly provided in the training sets. These models, such as GANs and VAEs, excel in generating realistic images, text, and even audio by learning the underlying distribution of the training data. This shift allows for greater flexibility and innovation, as models no longer depend solely on pre-labeled information, but can instead explore creative and unforeseen solutions.
This transition also highlights the importance of computational power and advancements in algorithmic strategies. With more powerful GPUs and better algorithms, we can train more complex models that move beyond the limitations of supervised learning. The rise of generative models, therefore, sets the stage for future advancements in AI, where the focus will be on expanding the boundaries of what machines can create and understand. Visual spatial intelligence is a topic that often overlaps with the fundamental distinctions in AI representations, specifically when talking about 1D and 3D representations. When we discuss language models, their core representation is typically one-dimensional, reflecting the sequential nature of text. This allows them to process sequences of tokens, which is ideal for handling language, but less effective for capturing the intricacies of physical spaces.
That's where 3D representations come into play, especially for tasks requiring spatial intelligence. Unlike 1D, 3D models incorporate the dimensions of space and time, providing a more comprehensive understanding of the physical world. This is crucial for applications like augmented reality, robotics, and virtual world generation, where understanding the depth, position, and interaction of objects within a space is essential.
The ability to perceive and model the world in 3D allows AI to interact with its environment in ways that a 1D model simply can't manage. By integrating 3D data, we're not just classifying objects, we're understanding their spatial relationships and potential movements. This distinction between 1D and 3D is pivotal in advancing AI's capabilities to truly understand and simulate the complexity of our world. When we look at the philosophical roots of language-based AI versus spatial intelligence, we see a fundamental divergence in how each system perceives and interacts with information. Language-based AI operates on a linear, one-dimensional stream of tokens, reflecting the nature of human language and its symbolic representations. This makes it adept at tasks involving reading, writing, and generating text.
In contrast, spatial intelligence deals with the multidimensional world, navigating and understanding space in a way akin to human perception. It's not restricted to sequences of tokens, but instead, it models the physical structure and dynamics of the 3D environment. This allows for richer, more intuitive interactions with the real and virtual worlds, capturing the essence of objects and their spatial relationships.
Picture a world where machines understand and interact with the 3D world just as naturally as humans do. This is the ambitious vision that led to the founding of World Labs.
The mission of World Labs is focused on unlocking spatial intelligence and making it accessible for a wide array of applications. The founding team, including renowned experts like Fei-Fei, Justin Johnson, Ben Mildenhall, and Christoph Lassner, brings a wealth of experience and expertise in AI and computer vision.
They believe that spatial intelligence is fundamental for creating more intuitive and interactive AI systems, whether it's for virtual reality, augmented reality, or robotics. By leveraging advancements in 3D modeling, generative methods, and large-scale computational power, they aim to push the boundaries of what machines can perceive, reason, and do in the physical world. Picture a world where your virtual and physical realities merge seamlessly. Spatial intelligence can bring this vision to life through various use cases. Imagine walking through a virtual world that is so richly detailed and interactive that it feels like reality itself. This technology offers immense potential for gaming and virtual experiences, creating fully immersive environments with ease.
Beyond entertainment, spatial intelligence can revolutionize augmented reality by enhancing our daily tasks. For instance, it can assist in complex repairs or offer real-time navigation in unfamiliar settings. Additionally, robotics can greatly benefit from these advancements, as machines with spatial intelligence can better understand and interact with their surroundings, performing tasks with greater precision and autonomy.
In the world of AI, team building is much more than just bringing brilliant minds together. It's about creating a diverse and multidisciplinary team that can tackle complex challenges from various angles. The combination of computer vision, machine learning, system engineering, and data sciences allows a team to not only innovate, but also adapt swiftly to technological advancements.
Multidisciplinary talent can significantly enhance problem-solving capabilities. For instance, having experts in both computer vision and machine learning may lead to novel approaches in spatial intelligence. It's through the interplay of different expertise areas that breakthroughs often occur.
Furthermore, the convergence of skill sets from various domains enables teams to address problems holistically. This collaborative environment often results in innovations that single-discipline teams might find hard to achieve. Moreover, fostering a culture where diverse perspectives are valued can drive a more inclusive and comprehensive approach to AI development. As we gaze into the horizon of spatial intelligence, it's evident that this technology holds vast, transformative potential. Imagine a future where our interaction with the physical world seamlessly integrates with immersive digital layers, enriching everyday activities from education to entertainment. Spatial intelligence will empower machines to not only navigate and understand complex environments, but also to create new virtual experiences that feel genuinely lifelike.
The long-term vision for spatial intelligence certainly underscores a paradigm shift. Integration with AR and VR can fundamentally change how we perceive and interact with the world. Robots equipped with spatial intelligence could handle tasks with higher precision, potentially revolutionizing industries like healthcare, manufacturing, and logistics. Moreover, the educational sector could witness a renaissance with virtual field trips and interactive learning environments, making knowledge acquisition more engaging and effective.
So, Jill, we've just heard a fascinating deep dive into the progress and current state of AI, particularly focusing on visual spatial intelligence. It's evident from the discussion that visual spatial intelligence is seen as fundamental as language, possibly even more so due to its ancient foundation in human development.
Indeed, understanding how AI models operate in a 3D and 4D context and their applications in generating virtual worlds, augmented reality, and robotics highlights a critical shift from text-based AI. The integration of such advanced AI into real-world applications opens up numerous possibilities for education, gaming, and even everyday tasks through augmented reality.
Another critical takeaway is the distinction between text-based and spatial AI models, focusing on the importance of 3D representations versus the one-dimensional sequence of tokens used in language models. This underscores the significant challenges and opportunities that lie ahead in further developing and deploying spatial intelligence technologies.
It's clear that while language models have dominated recent AI advancements, the potential for spatial intelligence to create interactive, immersive experiences represents an exciting frontier. The mention of potential applications across industries emphasizes the vast scope and impact these advancements can have.
To wrap it up, the exploration of AI and its trajectory, particularly in visual and spatial intelligence, promises to redefine how we interact with technology. With leading experts dedicated to pushing these boundaries, the future looks incredibly promising. Thank you for tuning in, and be sure to subscribe to our Is It Worth Watching channel for more insightful discussions.